Okay, welcome back to the last part of this today's sessions. Today we're gonna go to part 2, which is take a look at some of the, the most popular library in Python ecosystems. There are Numpy, Pandas, and Matplotlibs. And I guess before we go to our machine learning library, which is scikit-learn later, but Numpy, Pandas, and Matplotlib is more like the 3 most popular scientific computing library. I guess scientific related libraries used a lot in research and a lot of science stuff. Okay. Okay. So hopefully you guys get the part 2 from the zip files. And let's just look at Numpy first. Okay, so I'm gonna create numpy.ipynb. Okay, to motivate why do we have to use Numpy? Let's just let me just show you an example. Okay, so this one let me just copy this from my examples right here. I have to select the kernels. Okay, so if I want to sum all the numbers in this list, right? There are many ways you can do. The most Python way is, loop it, right? You can kind of create a variable called the sum number, and then you loop into each of the elements and you sum them up, right? And then I guess I want to find the average value of this thing. So the code that I show you is something like this. So you don't have to know everything, but just have a feeling that actually what I do is I'm gonna go through all the numbers in my array. Oh, did I ever tell you this tricks right here? Just to make sure. I don't know if I tell you this already, but if I were to have a list like this, I can do for n in number list. Okay, just like that. And if I were to print the number n, okay, I should get all the number in my list. Okay, because I think last time when I used the for loop, I think you were doing something like for n in range, right, like 0 to 10 or something, and you get 0 to 9, right? But if you already know, like if you have things in your list and you want to loop the content of your list, a better way is actually to not use the range function at all, but change from this into just the collection itself. So I can do n in number list, and the n, which is the index, well, it's actually no longer index, but this variable is going to become the item in my collection every time this loop repeats. Okay, so I think this one is a better better technique when you want to loop the elements in the array. So I'm not sure I told you this already last time, but just want to make sure that this is the technique I use in my code. Okay, so my code is right here. Okay. So first of all, I define the total summation, start with zeros, right? And len, again, this is the globally available function that gives you the number of elements inside the array. So this should give you 10, which is the size of the array. And then I'm going to go through all the number in my array, and then I'm going to sum them up. So the sum num is the total number, the total summation of all the numbers in the array. And then I'm going to divide it by the number of elements itself. So this is pretty much the average way. This is the calculation of the average value of the number in the array. And if I were to print them, I should get 5.5. Okay, you can verify that. If you add 1 to 10 divided by 10, you get 5.5. Okay. Okay, so this is just to tell you that if you are trying to do something like scientific, like statistic calculation, finding the average value is pretty important, right? You probably need that. So, but if you if you find yourself having to, kind of writing this calculation a lot, then I think the code will get very long. And also, this is not the optimized way to do it. It's slow, okay? So there's a better way to do it, which is to import the package that is designed specifically for scientific computation, which is Numpy, okay? So I'm going to import Numpy, okay? If you stop like this is totally fine. This is a valid way of import the libraries. But nobody do this, I guess, ever. The convention is to import and then change the name as NP. So this name NP right here, you can change it. But no one in the Python community change it. So everyone use NP. So I suggest that you use it too. So not to confuse any other people, okay? And if you want to find the mean value of the number in this list, all you have to do is just type np.mean and then just number list. That's all. Like that. You're good to go. Right? It's a 5.5. But we'll worry about other things later, right? But I just want to tell you that apart from the fact that you only got, from, I don't know, about 7 lines down to 1 line, the speed of NumPy is actually much faster than what you would write on Python. Because NumPy is actually written in C. C is a very low language. So if you use NumPy, chances is that your code's going to run faster too. So that's even better, right? So the first time you run this, it's going to load, right? But the second time you run it, it's pretty quick, okay? Okay? You have error? You have error? Can I see the error? Can you go down? And support operands. Can you run everything again, just to make sure? That's weird. Can you go up and see what happened? Can you make a new file? Oh wait, this is a new file already, right? Okay. So can you restart just to make sure? And can you run off? Run off. I have no idea why. Okay, can you go up? It has to be in the square brackets, not the curly brace. Wrong type of collection.
Okay.
Square brace, square bracket.
Just this one, yeah?
And then the enclosing one too. Okay, for you?
I think it's different.
NumPy. Okay, so you have to install NumPy. So can I see? So this is the place where you're installing NumPy. Okay. So that means that kernel doesn't have NumPy. Okay.
So it's not on my computer.
It should be on your computer because you already run that command already. But let me check real quick. Okay. I want to select, that, okay. Remember what we did here? You're finding the home folder, the VNV folder.
Yes, it was kind of.
Okay, so it's kind of confusing, yeah.
I
But
should go back to the VNV.
no. Can you find the .venv env folder for me?
Yes.
You have to do some keyboard thing.
Yes. I think so. It was.
Oh, I know where. I think you go here
Yes.
and then find the,
Here.
yeah, and you have to do the hidden folder.
Yes, something like this. The point.
There you go. And then do the bin and Python. Well, it should be, I think it should be this guy right here. Let's see. There you go. And let's, and then here, I want to do
This one.
is this the one?
I'm not really sure.
Because this is still using the wrong kernel.
Okay.
The wrong, I guess the wrong environment. So I want to use the one with the V and V. I'm wondering why it's not. It's. I mean, once you're picking it up, then it should know that there's another kernel that you can use.
Maybe just try the other one. Okay, maybe can you try maybe the other one? The one that's to the bottom.
This one is.
Which,
Nope. This one it's been worse. Okay. Let me make sure that your stuff. So if I go to, can you go to terminal for me?
yes. How do I do that? Not here.
Oh, okay. Maybe I can use this terminal. Okay. May I? You have to do current workspace. Okay. I think the best way is actually if you everything is in your folder. Can you drag the folder? So right now the workspace is wrong. That's why it gets confused.
Okay. So
Can you drag the folders in here first?
this one,
Okay.
but this one is in here already.
Okay. Can you drag this one's in here?
Again.
In here. There you go. And then don't save. No need to save. It's okay. Just do it again. Back in here. And then don't save. Okay. So this means that it's gonna center everything in your workspace, and then I can kind of set your workspace accordingly. So I guess the better way is actually go up one step so that you don't have to keep changing. So maybe this one is actually the one you want.
There's
Because
the S1 and S2.
Yeah, it's the same thing, right? But then you
Yes.
gotta trust this one too.
Yes.
Okay, can you trust it? Okay. Yes. So right here, it should work because now it's gonna remember all the. Okay, so let me make sure that the kernel is correct interpreter. I wonder why it doesn't pick up that V and V parts in here. Okay, let me try again.
Is it not this one? Is it not this
No, that's the one that come in your operating systems. But the one I want is actually the one that you just install. So I'll try it one more time. One more time.
How did we?
Uh,
That was so confusing.
you have to go up. Try to go up. I guess this one is go down, right? If you go up, you gotta go maybe like here or something.
Yes.
Does it work?
Yes, should be here actually.
The bin part. Is it right?
I mean, I can go again. Step by
Okay, yeah,
step.
go, yeah. Yeah, and then bin, and then select Python.
This This one?
Yeah, that one. Actually, yeah, it's fine. I think anything's fine. Okay, go. Okay, you got Python, and then let's do kernel. Come on, I need it.
So the problem is that it doesn't keep appearing here, right?
Yeah, let's
If
see.
you click on global.
Okay, let me close this one more time, and let's see if I do this. If it runs, it's actually picking up. Yeah, it's not picking up the right interpreter for me. Why?
Is this what you talked about in the very beginning when installing Python? Maybe.
See, I never did it in Mac before, so I'm a bit confused. So why this? So usually I can specify, for example, like here, I can add environments, and usually it works out okay. Like I can select interpreter, and usually it comes up here. Like for example, in Windows, like I can change it here, and then when I run file, it will pick up the right Python. Like right now, it's using this one right here, and if I were to change it into another one, then it's gonna pick up the new Python. Like, but now it's almost like it doesn't do that.
Maybe it's because
It's actually do that actually. Yeah, this is fine. Yeah, but Python is okay. But then I want the one with the V and V because that's the one that we're gonna be using for the whole class. เดี๋ยวก่อนของเราก็ไม่น่าจะเวิร์กถูกไหมถ้าด้วยสเต็ปเดียวกันเรารันออกป่ะนำพายอ่ะรันออกเหรอ
หมดเลย
ไม่วะขอดูหน่อยดิ so her computer works that's weird
แต่ว่าของหนูใช้เป็นอนาคต
อ๋อใช้ Anaconda อ๋อโอเคเราใช้อย่างอื่น
ใช่
เพราะฉะนั้นเราไม่ได้ใช้ UV เหมือนที่ผมทำเนาะ
ไม่ค่ะไม่ได้ลงอนาคตออกก็เลยมันก็เลยลิงก์มาอันนี้เลย
Is it working at your?
But she works because she installed other distribution called Anaconda. So she actually using that. She's not using the one that I had that I teach in the first place. Okay. For you guys, Anaconda is like the bloated distribution, like 2 gigs of running stuff. So I don't really like it anymore. It's too big.
Is it working at that?
Yeah. What about you? Like, how'd you get it to work?
Anaconda.
You have Anaconda too?
I have Anaconda.
Can I see? Yeah, you have Anaconda. So you installed Anaconda before, so that's why it works. But you don't. So, which I'm trying to avoid actually. So,
Okay. Maybe we can drag the VNV folder in here.
Maybe I can do this. Can I? Okay. So that's another way we can do, and we can go to
Just open the.
like this.
Yes.
Okay. Cannot find.
Is it this one already?
That's one for the other class. I want where's the forward slash?
Here?
Oh. No, the other way, the forward slash.
Here. This
Oh
one.
wow, okay. I need this one, AI class.
I have it already open, I think.
Okay. I need this one. And okay.
You can command and see.
ลงใหม่เลยครับ New way that. So right now it's creating this V, E, and V's in here.
Okay.
I think it should pick it up because it's local to this folder.
So
and you
it's
should be
only within VS Code right now.
within, I guess within folder, this folder.
Okay.
But yeah, you can.
But if I keep using this folder, then I should be.
You should be fine. Let's see. Let's hope that works. Okay, so I'm going to do that. See, now it's picking up. See? Okay. And now it should work. It's not picking this thing up.
Maybe you can go in here. Can you go in the one Numpy?
Like-
Numpy maybe.
Okay. Sorry. If I. It's not picking. Okay. Do you have the Jupyter?
Yes.
Jupyter. Okay, you got it. Okay, the right correct version. So you're good. This one's good. It's not picking up. Nope. Yeah. Can I just create it? Does it work? Use existing.
Maybe I should just install Anaconda.
Yeah, that would be the last thing I want to do. But yeah, if it has to be, it's might. Yeah, this doesn't work here.
Why is it not picking up the
Yeah,
environment?
I don't know. It doesn't see it. Yeah, see, I'm
Maybe you can
selecting.
drag the VNV folder inside the S2 folder.
Yeah, that would be okay, but then you have to you will have multiple VNV folder in this class, which is not ideal. I don't want you to have to install like a lot of VNV. That kind of defeat the whole purpose. Like actually, I want you to have just one folder in your home folder, and then you keep using that.
Okay.
But it's not picking up. So let me just try one thing real quick. So in Mac, maybe I have to update it. Okay. Okay. Now it's picking up. Can I run it? Yeah. Okay. So it's actually in Mac it's the opposite. So you gotta update it. In Windows, you don't update it.
Ah, okay.
Because I use Windows, and when I update it, it broke.
You recommended us to
Yeah.
install not the latest.
Yeah, but now for this, the latest one works.
Okay.
Now it works.
Thank you.
Okay,
very much.
so the reason, so now actually you don't even need this one, because
Okay.
the reason is that your Jupyter extension is kind of.
Because now it's picking up the actual one that we want.
Okay, so right now it's picking up this one. So you can leave this as it is, but if you feel like it's it's redundant because you already have this folder inside your home, you can delete this one, and you can kind of point it back into the one in your home folder.
Okay, but
But-
if I leave the zero, it will work.
So it should work.
And
Okay.
if I close VS Code and next week I
try.
come back and open
Why
it.
don't you try it right now? Let's do this one, AI class.
It's,
And now just run it. There you go. It works.
thanks.
Okay. So yeah, that's who would have thought that in Mac it's a little different. Okay. Where were we? Okay, we are at Numpy. And okay. Okay. So right now, hopefully I motivate you to the fact that when you are doing something scientific, you should use Numpy due to speed and conciseness of your code, and it will help you a lot. Okay, so the most important thing about Numpy is that you have to keep in mind that you are working with something called Numpy array. Okay, so if you were to do something like this, 1, 2, 3, right? This is Python list. Python list is all right for general usage, but if you want to do scientific computing, you better use Numpy array. So we're going to convert this Python list into the Numpy array. So what I usually call supercharge it. You supercharge this one to be even more capable, okay? So we're going to do np.array. And then we're going to put the list inside it. So that's how you supercharge the normal Python list into Numpy array, okay? And then I'm going to put this inside a variable called a, for example, and I want to run it. It's not a class. It's a module. And just keep in mind that array is a function. It's a function in Numpy library, and it accepts anything collection, and it outputs the Numpy array. So let's check if it's Numpy array, right? I'm going to go to the terminal, and I'm going to do Jupyter and then you can see that my A, the type is called ND array. So that is NumPy array. So that means that you already supercharge your objects basically. And you can see that the size is 3, but as you can see that even if you do one, just a normal list, right, the size is a little different, right? If I were to do another variable called B, right, B equal 1, 2, 3, you can see that B is just a normal list with a size of 3. But for NumPy array, this is called tuple. Tuple is the collection that you cannot change the value of the elements. But the thing about the tuple is that this is telling you that this is actually kind of like vector already. Because in scientific computing, when you have lists of number, it's either vector, the matrix, and then the high dimensional tensor. So already, this is already like mathematics equivalent of a vector already, like this type of size right here, okay? Okay, so what can we do with this, right? The thing that I like to do first is like, I want to see what is the shape. Let me just clear everything, and then I want to run it again, okay? Okay, I can do A dot and then size. Okay, that's probably the things that you will do. Sorry, shape. Sorry, not size, shape. Okay, and as you can see, that shape, this is 3. So this is called the one-dimensional shape. Right? It's like vector. Okay, and you can see that if you want to create something like a matrix, this is vector. Then you can do what's it called, nested array, nested list. Okay, so let's do this np.array. But now I'm going to do list, and inside this list, I'm going to have another list, and it's go like 1, 2, 3, and then comma, and then 4, 5, 6. Okay, so think about this as the matrix, which has rows and columns. So in these constructions, I have, I guess I have 2 rows and 3 columns. Okay, and if this looks kind of complicated, let's see what it comes out from the NumPy array. Okay, so I'm going to take this as B equal, and then we're going to print B. Okay, and as you can see right away, this is more like matrix. It has rows and columns, and it actually can perform like matrix operations too. Which, I mean, if you are working with just the Python list, and you're trying to do matrix operation on NumPy on Python list, good luck. It's going to take you a long time to code, but then for the NumPy, it's already built in. Okay, so this is the 2-dimensional array, or what we usually call the matrix. Okay, and you can check the size of it by doing b.shape, and it's going to show you that it has 2 rows and 3 columns. Usually the order is the row and the columns. Same thing with the matrix convention. The first number is usually the row number. Okay. So try that. So if you want to have another row, let's try creating another row into it. So I can do comma in here and adding another nested list in here, and I can do 7, 8, 9. Let's see what it is, right? Now I got 3 rows and 3 columns. And if I do the shape, I should have 3 by 3 matrix, okay? So let's try creating a bigger matrix just to get a feeling of what the NumPy array is doing to your data, okay? If you're old like me, or if you I don't know, work with old professors, then you might be working with MATLAB. I don't know if you guys heard of MATLAB before. MATLAB is something I used when I was in a grad school because it's the only thing that works in terms of scientific computing that is not, like really low level. But nowadays, it's completely I guess, replaceable by Numpy. It's essentially MATLAB killer for me. So right nowadays, if you are, I guess, if your professor is not, I guess, not tied into the old technology, you should be using Numpy instead of MATLAB. But MATLAB still has some of advantages in terms of the Simulink. So if you like spend a lot of money buying like all the Simulink modules, then it might make sense to still keep using MATLAB. But if not, I think Numpy is totally capable of replacing MATLAB already. Okay. So that's good because free. This is free. Okay. Okay. So next up, I want to kind of motivate you into seeing that once you work with Numpy array, a lot of things make sense in terms of mathematics. Okay. I'm going to use the example from my code right here. When I say NumPy array versus the Python list. Okay. So right here is the Python list because if you just do square brackets, it's the normal list, right? And if I were to print A list plus B list, so if you add lists together, what happened? As you can see that in Python convention, adding list means that it concatenates the list. So it makes the list longer, right? Which is, I guess, okay for a general usage. But if you are going to use it in mathematics or scientific computing, when you have a list of number, it is generally a vector. If you adding vectors, you are not concatenating vector. You are adding the element of the same basis. So that means that the first element of the two vectors are adding together, right? It's a vector addition. And you don't get that behavior right out of the box using Python list like this. But you do get that behavior from NumPy array. So let me show you this, okay? So I'm going to change just one thing, right? Before I declare after I declare the list, I'm just putting the list into the NumPy array function just to supercharge it, okay? And now if I were to print, right, A NP plus B NP, see that? I get the correct vector addition. So, and this is not the only thing, but this just show you that like a lot of mathematical operations can be done with NumPy naturally too. Okay, and you can also try other mathematical operation with vectors. For example, you can do vectors plus the matrix, right? Vector plus matrix and see what it does. Okay, see if it makes sense to you. Okay, so I have, let's see, I have the vector right here. Matrix right here, right? If I were to print C, NP, right? So I want to add this. And then I want to add the vector, right? So I have my A vector, which is this guy right here. So let me just put it in here. I have A, which is 1, 2, 3. So if I were to print both of them, right? Wait, NP, like that. So I want to add this vector into this matrix. You can, right? So you can do print A NP plus C NP. I guess if my linear algebra is still intact, then what you're doing is that you're adding the row into, I guess you're adding vector into each row, That's how the operation works in linear algebra. So you don't get this behavior ever in the regular Python list, but you do have this type of behavior in NumPy array. And then multiplication, division works quite nicely too. Okay, so if you feel adventurous, you can try metric multiplication in NumPy. It's pretty easy too.
มีใครที่สั่งกับข้าวหรือเปล่า
ไม่มีครับครับไม่มีครับเชิญเลยครับ Okay, can I go? Can I move on, or you guys still have problem or typing? Okay. ผมพยายามจะช้าลงแต่คุณต้องบอกผมด้วยว่าผมช้าพอหรือยังไม่งั้นผมก็ไม่รู้ว่าผมต้องช้าขนาดไหนนะไปให้สัญญาณหน่อยว่าไปได้โอเคไปได้นะโอเค let's go so this is one way of creating NumPy array but it's not the only way there are other ways that you can do for example you might want to create just a bunch of zero matrix you might want that right so it's np.0 with s okay inside, you're going to give them the row, and I guess you're going to give them the dimension. But in the dimension, you can give them in a term of a collection called tuple. Okay, so this is probably one of the few times that you're going to use tuple, right? So I'm going to do 2 by 2 matrix. So just remind you, this part with the parenthesis, it's a collection called tuple. It's kind of like list, but it's the immutable list. Okay. Let's try that. There you go. You get 2 by 2 zero matrix. So let's change them. 2 by 4. You got it, right? 4 by 4. You got it. And you can even do 3 by 3 matrix too. And that's going to be, that's a lot. So if you do 3 by 3 matrix, it's kind of hard to visualize. It's going to kind of do the cross section for you. So, and you can do 4 by 4 matrix too. There's nothing prevent you from doing multi-dimensional matrix in NumPy. It's totally perfectly fine, and it's built for that actually. Okay, so the only thing that I want to make sure that you take notice is that if I want to do one-dimensional matrix, it's actually, the syntax is actually just for and comma. I don't know if you find that kind of strange, but actually if you don't do comma, like if you just do for, I think it's give you error. Actually it doesn't. Okay, so that's fine. Forget what I just told you. Okay, but when you are writing tuples, if you just want one, I guess one item in tuples, you don't just write for like that. You write for with comma, because if you just write for, it means just parentheses with the, I guess the parentheses just mean order of operations. But if you want the parentheses to mean tuple, you got to put comma somewhere. Like this is one-dimensional tuple. I guess tuple with one item. Okay? Okay, I don't know if it makes sense, but I just wanted you to notice that sometimes you might encounter something like this, and that is the one item tuple. Okay? All right? So you can do zeros, you can do 1, no problem. 1 with S, you got 1, right? You can do maybe do 4 by 4 matrix with 1, like that, right? You can do full, which is just do number, right? Full, and I want to do number 100, I get 100. like that. So 2 arguments, one is the dimension, the other one is just the number to put in, right? And you can also do identity matrix. I guess that gets used a lot in scientific computing, right? So it's going to be I. So a lot of this actually come from MATLAB. MATLAB also have the function called EYE, I. It means identity matrix. Why doesn't it work? Oh, because it only get the, like that. Okay, just the number, give you the number, okay. Okay, so 1, 0, just any number, and identity matrix, you're good, right? And another thing you might want to do in the future is random number. So let's do random number. It's going to be np dot random, and it's going to be dot random, okay? So let me just mention this one real quick, because you might notice, like, why do we have to use a lot of this? Like, why do we have repeated random in here? So the way that Python is work is called module system, meaning that if you write the code and your code gets too complicated, you're going to break up into folders. And if you look inside the folder of Numpy library, there is actually a folder called random. And inside the folder random, there's a file called random.py. So the first random is accessing the folder. This is accessing the actual file. So that's why you have the repeated words right here. Sometimes I guess the library is written in multiple deep folder, and you're gonna have to like know where to go into the actual functions. So that's why it's like this, okay? But just use it, okay? So if you wanna construct a random matrix, just keep them the size, for example, like 4 by 4, random number matrix. There you go. And lastly, I think something that might be useful is to create the array with, the consecutive number, right? So np.aRange, that's going to give you the consecutive number. For example, 100. It's going to give you from 1 to 99, okay? It's aRange, okay? Start and stop. And again, it has the same convention with Python. Remember, like the second number is going to be that number, but then the one before. Like the concept of the one before actually applies here. So if you go from 1 to 100, it actually gives you 1 to 99, which I also find that quite confusing, even for now. I don't know why you just give like 1 to 100. I feel like that would be more natural, but no, in Python, like anything with list, the last number, you gotta keep like the one before it. Yeah, that's how it works, okay? And also, if you wanna be a little bit more concise, you can give them the key value pair, like I told you, like when you call the functions, you can give them the key value. So start equal, end equal, and then step equal. Step meaning you're gonna steps, doesn't work. End, stop, okay, stop, not end, okay, like that. So this one is going to give you the odd number. So remember, like when you were writing Python last time with the for loop, I'm saying that only print the even number. Now you have another way to do it in one line, which is to do numpy.aRange. If I were to do like start from 0 to 100 and step 2, I got even number array. See? Mm-hmm.
Do you have to type start, stop, step, or can I just give them the number?
Yeah, I can do this too. It will be the same. But you have to remember the order. That one the same. And if you want to check, what does this mean, then you can always look up the NumPy documentation. So I'm doing numpy.aRange. Just search like this. And let me show you how you look up the documentation. So here, this is a function. it's going to have start, stop, and step. Okay, so if you don't give them any keywords, it's going to follow this order.
But if I give the keywords will override the order.
If you give the keyword, then I can even do this. I can do step first, like that, and then do start 0 and stop equal 100. It will perform the same, and this is a much better way to do. Mm-hmm. Okay. If there's no further questions, so I'm going to move on to indexing. Okay. So this is also quite nice in terms of working with multi-dimensional array, because you got to be able to select things like within that whole objects, right? Usually that's the task you want to do. So let me just copy some of the example from array indexing. So this is the I guess 3 by 4 matrix. Let me just make sure. So if I print A, then yeah, this is 3 by 4 matrix, okay? So if I want to select the subset of this number, that's something that you might want to do in, you know, like linear algebra, right? So I can do a similar thing with selecting substring, okay? I can do A, right, inside the brackets, okay? And since this is the two-dimensional array, I can also do like a two-dimensional selection, which is even cooler, right? I can do maybe from 0, which is the first item in the row dimensions, right, up until whatever, I can do 4, okay? Remember, if I do 0 to 4, that means that it goes from the first item in that dimension until the 5th one, but actually go back one step. So it's going to go to the 4th item in that dimension. So that is the row that I want to select, which actually this one can exceed the row that I have. So I'll go back a little bit, maybe to 2. So that one's going to select the first 2 row, okay? And I'm allowed to do something like this, which is really nice. Because if I have two-dimensional matrix, I want to select the column, which is I want to select the subset of the column. So I want to do the first column until the 3rd column. So remember the 3 at the back is the, I guess it's item number 4 with exclusion. So it goes to the 3rd column. So if I were to do this, I can get just the first 2 rows and the first 3 columns, which is a really cool way to select your data. I think it's very, very natural, like when you do linear algebra. You might want to select something like this instead of, I don't know, going to like the weird way in Python, okay? So that's a big plus for Numpy array, okay? So why don't you help me select only just 1, 2, 3, 5, 6. How about this? Can you help me select 6, 7, 10, 11? Can you do that? Can you think of a way to select 6, 7, 10, 11? It has something to do with your index right here, but I want 6, 7, 10, 11. Okay, so let me give you some hints, okay? So if I want to do 6, 7, 10, 11, that means that, so think about the dimension first. The first dimension is a row, so I want to select the last 2 rows, okay? So it goes from the second row to the third row, right? So I'm gonna go from second is index 1. Index 1 is the second position, so 1, right? But then the third one is actually, you have to do the fourth and then goes back, right? So you gotta do 3. So 3 means, 3 is the fourth item, but 3 in the second after the colon is the 3 with exclusion. So that's why it's 1 to 3. That's gonna give you the second and the third, right, the row. And for the columns, I wanna do the second and third columns. That means that it's gonna go from 1 to 3 also, like that, okay? And if you find that confusing, I feel your pain, because even for me right now, I still take a lot of, I guess I have to think about it. It's not natural, even for me right now, but that's how it works, okay? Okay, we are running out of time, so let me just show you some of the things that you might encounter. Boolean indexing, probably not, so I'm going to skip it. Reshaping array, something we use a lot, okay? So let me show you, okay? So if I were to do np.aRange, right? And I'm just going to use the code from my example, just to make sure it's working, okay? So if I were to print this array, right now it's the 3 by 4 matrix, but sometimes I want to change the dimension, right? I'm going to change the shape. So I can do a.reshape. Remember that A is the class instance of Numpy array, right? So it does have a lot of methods. One of them is reshape, okay? And when you reshape, you can tell it what size you want afterwards. So if it's 3 by 4, I want to do 4 by 3. For example, I can do 4 by 3. So inside a tuple, and there you go. You already have 4 by 3. Okay. So let me just print them out. Okay. So you can try other shapes. For example, I want to reshape into 2 by 6. So, as long as the number turns out to be 12, then you should be fine. You can do 2 by 6. I can also do 1 by 12. So you can do 2-dimensional array. I guess you can do 2-dimensional array with just 1 row. That's also possible too. Okay, so you can reshape things into different dimensions. So that gets used quite a bit when you, I guess when you think about like machine learning stuff, then sometimes you gotta reshape your array. So that's one quite useful. And I just want to point out that the array operations also works. Let me just show you this one, okay? So if I have a matrix, right, I can do a lot of matrix operations, which is pretty cool. Like I have this 2 by 2 matrix. I can do, I guess addition is pretty easy, right? np.add x and y. So if you add the matrix like this, it's doing the elements-wise additions. And you can also do multiply. So multiply is a bit interesting. Let me show you this. Multiply x and y. Okay. Okay. So addition is easy because it adds the array elements together. But if you do multiply, you can see that it's a little bit interesting because when you do multiply, it's actually doing it element-wise. It means that it's going to do 3 times 2. This 3 times 2. So elements by elements, right? But this is actually not the metric multiplication. Like if you do matrix multiplication, this is not element-wise operations. And if you want to do matrix operation, you're actually doing something called mat mul. So NP dot matrix multiplication x and y. And you can see that the results are different. So just want you to take note that if you're working with NumPy array, some of the operations are element-wise. For example, multiply. You are multiplying elements of the same dimension number. But that's totally different from what you call matrix multiplications, because that involves non-element-wise operation เหมือนที่เราเรียนมัธยมอะครับนะคูณเมทริกมันไม่ได้เอา element มาคูณกันถูกป่ะมันต้องใช้อะไรอย่างเงี้ยแต่ผมเคยเรียนทำไม่เป็นละนะเพราะฉะนั้น be careful this is probably not we're not gonna use like this a lot because scikit-learn kind of abstract everything from us already but NumPy allows you to do element-wise versus the kind of like the non-element-wise operation. So keep in mind that there are differences, okay? And also division is something that you might need, you might want to take some note because again, division you can do element-wise division and also matrix division is like finding the inverse of the matrix. So it's totally different, okay? So if I do np dot divide, that's the element-wise operation. Divide, right? If I do a, x and y, you're gonna get element-wise division. So that's just that's the pair with the same element dimension number. But for the actual matrix division, you're going to do, I think, which one is it? I don't have it here. But if I were to guess, I probably, well, maybe let me just find it, okay? NumPy matrix division, right? That's divide, but okay, it's called the inverse. Okay, so I have to do inverse. Okay, so yeah, so I guess the division of the matrix is like multiplied by its inverse. So I'm gonna do maybe np dot matmul. I can do x dot inverse. Nope, inverse. No, this is not Python. Sorry. Okay, I don't want to bore you with this example. Okay, I'll look it up because I don't remember off the top of my head like how do you do division with like actual inverse, but I'm sure there's a way to do it with NumPy. But that's the example that sometimes the tensor operations and the element-wise operations might not be the same. Okay, and lastly, before we go, I just want to show you some couple useful functions that attach into all the NumPy's array. For example, sum. If I were to have the array like this one, okay, this guy right here, if I were to print x, I get 2 by 2 matrix. Okay, I can do x dot sum, remember? Not remember, but all the NumPy class instance, they do have this type of useful the operations that you use a lot, sum. For example, this one is going to give you the summation of all the elements inside the array. But you can also do x.sum, but then you give them the keyword axis equals 0. So it's going to sum, I guess, down. And if you want to sum to the right, you can do axis equal 1. Then it's going to sum on the, I guess, the column directions. 3 and 7. So that's, this type of operation is kind of useful because if you have to write it in Python, it takes time, but NumPy is already built in, right? And also you can do mean. This one we already used, right? x.mean, so that we can get the mean value of all the numbers in our array. But again, you can also do mean that move along specific axis, like mean of the axis 0, that means mean of the direction going down. So you get that? That's the mean of the down direction, right? It's a column mean, for example. And you can do mean of the rows. That's the mean of row. Okay, similar things, you can do x dot max, right? So that's the max value of all the numbers in the array. But you can also do axis too, which is kind of nice. So you can do axis equals 0. So that's going to be the max along the column. And you can do max along the row. Okay, and similar thing with min. Okay, so very useful. And I guess in your journey forward, apart from this class, if you ever do scientific computing in Python, yeah, definitely check out Numpy. All right. Okay, so I think we run out of time, and yeah, let's go to lunch. All right. Thank you. See you next week.